Next one, we will talk about how to apply Markovnikov's rule on unsymmetrical alkene. So previously I have shown you how to use ethene react, how the mechanism looks like for ethene reacting with bromine. Okay, now that way it's easy to predict product when first of all you have symmetrical compound like this one, like ethene as well as like this one, built two in. Okay, it's symmetrical, so whenever I want to substitute the electrophile, I can substitute in either of the CC bond. Okay, and I will also have no problem even if I have a propene CH3 H and then H2. Even if I have a propene, but if reacting with non-polar molecule like the Br2 and the H2, I will also have no problem finding the product, the major product, because uh, both will have the same electrophile. Okay, both will have the same substituent into it. Okay, but I will have problem if there is a case where it's unsymmetrical alkene like the propene reacting with the polar type of molecule, like for example HBr, HCl, and water. So I'm going to show you one example which is in your syllabus that you need to at least know this. They could use other example as well, but the basic example that we are going to use would be propene and HCl. I'm going to rub off this part so that I can use more space to explain later. Now let's look at propene. It will still go through the main two steps of electrophilic addition, but we will predict two intermediate. Okay, I will stop at the intermediate product. So you have the CC, and this one is the CH2. All right, I'll just write in simplified form first, and you have the HCl. So first of all, you need to determine which one is the electrophile. In order to determine, you need to find out which one is a delta plus, because an electrophile again will be positively charged or more positive. And this one is not that hard compared to the BR because it doesn't need to be polarized. It's a polar molecule. Automatically I know H is delta plus, Cl is a delta minus. So I move here, there will be electrophilic attack and heterolytic fission. Remember the arrow pointing from electron rich or direction of lone pair or any electrons or more negatively charged towards a less negatively charged. All right, and what you get is the two possible intermediate product, because this H will have a choice to go into the carbon on the left side or the carbon on the right side for my view here. If H goes into the carbon on my left side, I'm going to get something like this. H, C, and CH and CH3. I will use another color to represent the H here. Okay, this is the H that comes from the Cl, HCl. Now it carries the charge, so positive charge over here, and together with the release of chloride. Next one, it will take place as the carbon on the right side, H will be bonded with the carbon on the right side. If so, then it will be like this, CH3, and the plus would be here. Okay, with the chloride. Okay, so so there will be two possible products, but which one is the major one, which one is more favored by the formation by the carbocation, which one is more stable? The one that is more stable. Now remember, we don't talk about the stable product, we don't talk about no, stable reactant or stable product. We are talking about the stability in terms of the intermediate product that are formed. So in this case, there are two possible intermediate products. The first one, if Cl attacks, if Cl forms a bond back with the carbocation over here, the result that I got would be, okay, this will be my result. The product would be CCHCl CH3. And if Cl attacks from here, my product would be H2CCl CH2CH3. This is 1-chloropropane. This is called 2-chloropropane. Okay, now it's not a matter of the product. The product is not the main factor that affect which one is major and which one is minor. It is, again, I say, the intermediate products. You need to look at the intermediate product. So this is where you apply the Markovnikov rule into analyzing the intermediate product. So what does Markovnikov's rule say? Okay, I'm going to write very small here. It says that the formation of the product, of the major product, will favor the more stable intermediate product. Intermediate product, not products, but intermediate product. In other words, maybe you can say carbocations, the more stable carbocation, okay, over here, carbocations. Now, how to make it stable? Then you need to explain what does Markovnikov's rule say. Markovnikov's rule say LQ group, okay, LQ group, okay, it's a bit messy, it's a bit crowded, so I'm going to just throw it right over here. Now it says LQ group, okay, that is bonded, that are bonded to the C+, not just any LQ group. Those LQ group that are found over at other side doesn't matter, but it is the LQ groups that are bonded with the C+, okay, the C+, that means this C. All right, we are focusing on this C, okay, will give positive inductive effect. Or in other words, in my slide, it mentioned electron donating group. Okay, they push, okay, they tend to quote unquote push the electron towards the C+, thus making reducing the C+ charge density, okay, or in other words, making it less positive. If it's reducing the C+ charge density, if it is reduced, then it will become less reactive towards the Cl minus over here. So if it's less reactive, then I will consider it as more stable. Okay. more stable. And lastly, you can say that more stable, so that goes back to the ultimate impact or ultimate factor. The more stable the carbocation ion or intermediate product, okay, the more favorable, okay, to become major product. Okay, so coming back over here, let me see whether this marker work or not. Alright, I'm going to count how many R group. R group means any alkyl group. Could be CH3, CH2, CH3, C2H5, C3H7, counting from those alkyl group bonded to C plus over here. So if I count from here, it would be 1 alkyl group and 2 alkyl group, which is 2 CH3 over here. This one is a H, it's not an L group. Okay, so there are 2. Compared to this C plus, you will have now only the alkyl group attached to here. You cannot count this as all 1, 2. It forms one bond with the C plus, so I will consider this one as my entire alkyl group, which is actually C2H5 group. It's one group, okay, one group altogether. And there are 2 H plus over here, which is not considered an R group. Okay, so there you have it. I have 2R versus 1R. So of course 2R will be more stable. Okay, 2R will be will give more stability to the intermediate product, because the more R group, the more the positive inductive effect, the more stable it is. Okay, so therefore, in conclusion, because of that Markovnikov rule, I will say this will be my major product, okay, and minor product. In fact, sometimes when they ask you about major product, you can just directly give this one. You don't have to give this one. Good? Clear? All right.